You know, when you think of a data center, you probably picture these glowing, almost futuristic hearts of our digital world. And you're not wrong. They're the central nervous system for just about every organization out there, pulsing with our most valuable, most sensitive information. They really are our digital fortresses. But here's the thing about any fortress. They all have weaknesses. So let's take a look at what happens when those walls get breached, and just how incredibly high the stakes really are.
$4 million. That's not a typo. That is the average price tag when a data center's defenses fail. And this isn't just about some stolen files. We're talking about a catastrophic financial event that can absolutely cripple a company. So how on earth does this keep happening?
So at its core, what is a data center? Well, basically, it's the building, or sometimes the whole campus of buildings, that houses all of an organization's most important IT gear. Your servers, your routers, your storage systems, it all lives here. And because it's the one central hub for everything from intellectual property to all of our customer data, you can see why it's such an incredibly attractive target for attackers.
Okay, so we spend billions and billions of dollars on cybersecurity, right? We build these huge digital walls and sophisticated alarms, but what if the biggest threat isn't trying to smash down the front door? What if it's already inside, creeping around in a blind spot that most of our security systems can't even see? The ways attackers can get in are way more varied than you might think. It's not always about cracking some super complex code. Nope. Sometimes it's as simple as a weak password or a mistake in how a piece of software was set up in the first place. It can happen through remote access points, which have just exploded with cloud computing. But two of these are especially sneaky: getting physical access and the insider threat.
And this is where it gets really interesting, because this brings in the human element. An employee, and it doesn't matter if they're malicious or if they've just been tricked, they have legitimate access. They can walk right in. And all it takes is for them to plug in one single compromised device, and suddenly the entire fortress is breached from the inside out.
And this, right here, is the core of the problem. Our security software, all those fancy programs we rely on, they're designed to watch network traffic and software behavior. But they have a fundamental blind spot. They have zero visibility into the physical hardware they're actually running on. It just can't tell if the keyboard it's taking commands from is legitimate, or if it's something way more dangerous in disguise.
So, attackers know all about this blind spot, and you better believe they are actively creating tools to exploit it. Let's dig into how they can turn a simple, everyday piece of hardware into a master key that unlocks everything.
Their weapon of choice? It's called a rogue device. And this could be anything: a USB drive, a mouse, even a simple network cable that's been physically tampered with to carry out an attack. To you and me, and more importantly to the security software, it looks completely normal, but it's a Trojan horse. And this picture illustrates perfectly how it works. An attacker can use one of these rogue devices to secretly put themselves right in the middle of a communication line. From that position, they can just listen in, they can steal login credentials, they can even inject malicious code. And all of this is happening at the physical level, completely under the radar of traditional security. You know, this quote from the source material just says it all. These manipulated devices, which are technically called human interface devices, or HIDs, are seen as totally legitimate by the very software that's supposed to be protecting the system. So a device that tells the computer, "Hey, I'm a mouse," can suddenly start acting like a keyboard and typing in malicious commands, and not a single alarm will go off. Okay, so now we see how the attack works. But what happens when it succeeds? Well, this is where a clever hack turns into devastating, real-world consequences. A successful breach isn't just a technical problem, it's a full-blown corporate catastrophe with a massive, massive price tag.
So when we look at that $4 million figure, where is all that money actually going? What's really shocking here is that the single biggest cost at 36% is just lost business. Customers lose trust and they walk away. And look at the other parts. The cost of recovery and the long-term damage to a company's reputation are almost just as big. The pain from one of these attacks is felt for years.
And the damage isn't just financial. Think about the operational hit. The average downtime from a ransomware attack is over 12 days. That's almost 2 full weeks where a business just grinds to a halt. You combine that with huge regulatory fines and the long, painful struggle to rebuild a damaged reputation, and you can really see why these attacks are just so incredibly devastating.
So if the problem is a blind spot that our traditional tools can't see, then the solution has to provide a totally new kind of vision. We need a new kind of guardian, one that can operate at the most fundamental level of our infrastructure.
And this slide just shows the paradigm shift perfectly. On one side, you have traditional security, which is reactive. It waits for a threat to pop up on the network.
On the other side, you have this new approach, which is all about prevention, using something called a cyber digital twin. Think of it like a perfect digital blueprint of your physical hardware. It focuses directly on that physical layer, giving every single device a unique digital fingerprint. And it flags anything that doesn't belong or acts strangely the very moment it gets connected.
So how does it work? It's basically a simple three-step process. First, visibility. It gathers data from the physical layer of every single device that's plugged into the network. Second, analysis. It uses that data to create that digital twin, that perfect replica, and then uses machine learning to spot any weird behavior. So for example, it can immediately tell if a device that says it's a mouse suddenly starts typing like a keyboard. And finally, mitigation. It automatically blocks any device that's unknown or that starts acting suspiciously.
The benefits here are pretty clear. You get complete visibility and total control over every single piece of hardware you own. Those threats from rogue devices, they're stopped automatically before they can do any damage at all. And this part's really crucial. You don't have to build a brand new, perfectly clean network to use it. It can be put to work in existing complex environments.
And that really brings us to the final crucial question. In a world of smart devices, the Internet of Things, and just interconnected everything, our trust in physical hardware is absolute. But maybe it shouldn't be. Perhaps the real question isn't whether our software is secure, but whether we truly know what's plugged into the wall.